Alright, in this video we're going to look at some trigonometric equations and identities. Now remember the difference between an equation and an identity. An equation can be solved for the variable and it's only true for particular values for the variable. An identity, however, is true regardless of what number is plugged in for the variable. Identities are always true. And so the way that we approach these two types of problems is different depending on what it is. In this first example, notice that the directions say solve the equation. Whenever we see solve the equation, that means that we want to get the variable, in this case x, we want to get it by itself. We want to know what it's equal to. And so in order to solve for x, I notice that there's a squared in this equation. Whenever we see a squared, the way that we're going to solve that equation is by factoring. And if I'm going to factor, I need one side of my equation equal to 0, and we already have that here. So we're ready to go ahead and factor here on this side. So to get 4 cosine squared, we're going to multiply 2 cosine x times 2 cosine x, and then numbers that multiply to give me 1 are 1 and 1, and my signs are going to be plus and minus. 4 cosine squared minus 1, that's a difference of 2 squares. And so we factor it just like we factor a difference of 2 squares when x is the only variable. Now that I have this factored, I'm going to set each factor equal to 0. So 2 cosine x plus 1 equals 0, and 2 cosine x minus 1 equals 0. And we're going to solve each of these for x. So I'm going to subtract 1 from both sides. 2 cosine x equals negative 1. And then we're going to divide by 2, and I get cosine x is equal to negative 1/2. And I want to find two answers for this equation from my unit circle. The question here is, at what angle x is cosine equal to negative 1/2? Well, I know cosine is negative in quadrants 2 and 3, so I should be looking in those quadrants. And I can find that cosine is equal to 1/2 whenever x is equal to 2 pi over 3, and then also in quadrant 3, 4 pi over 3. So those are my two answers for this first factor. On the other side, I'm going to solve for cosine x again. I'm going to add 1 to both sides. And then we're going to divide by 2. And cosine x is equal to, this time we're getting positive 1/2. Cosine is positive in quadrants 1 and 4. And the angles where cosine is equal to 1/2 are pi over 3 and 5 pi over 3. And so those 4 angles are the solutions to this equation. Let's look at another example. Here we have 2 sine x equals cosine x. Now this one is a little bit strange because I have sine and cosine. I have 2 different trig functions here. But we're going to use factoring again to solve this equation. I'm going to subtract cosine x over to the left so that I have one side equal to 0. So I'm going to have 2 sine x cosine x minus cosine x equal to 0. Now I have 2 terms here that are being subtracted, and both of those terms have a cosine x. And so I'm going to factor that out. If I factor out a cosine x, then in my first term I have 2 sine x minus, and in the second term I'm just left with 1. Still equal to 0. So now I have this factored. I can set each factor equal to 0. Cosine x equals 0, and 2 sine x minus 1 equals 0. Notice now that I have the factors split up, each one equal to 0, each equation only has one trig function. My first equation has cosine, the other equation has sine. So I've got them split up now. So let's start with cosine x equal to 0. I'm looking at my unit circle, looking for which angles have a cosine of 0. And that, of course, happens at x equal to pi over 2 and 3 pi over 2. Alright, in my other equation, I need to get sine x by itself. So I'm going to add 1 to both sides. and then divide by 2, and I get sine x equal to positive 1/2. So when I go to my unit circle, I know that sine is positive in quadrants 1 and 2, and sine, the angles that have a sine of 1/2 are going to be the angles with denominators of 6, pi over 6, and 5 pi over 6. And so those 4 angles are the solutions to this equation. Okay, let's move on to an identity. Now notice here, my directions say verify the identity. This is where we're trying to prove whether or not these two things are always equal to each other, whether tangent plus cotangent is always equal to cosecant times secant. So in order to do this, I'm going to put up a wall between these two sides, and we're going to work on the two sides separately. Now, we talked in class about some different strategies that we can use to do this. One of those strategies is to get everything in terms of sine and cosine, and I think that would be a good place to start here. So over here on the left, I'm going to change tangent theta to sine theta over cosine theta. And then cotangent is going to be changed to cosine theta over sine theta. And I can do the same thing on the other side. Cosecant is 1 over sine theta times secant, which we can rewrite as 1 over cosine theta. All right, so now I have everything in terms of sine and cosine, but my two sides are not the same yet. So let's think about some of our other strategies. Notice that on the right, I have two things being multiplied together, and on the left, I have two things being added. Typically, when we see two things being added, especially fractions or rational expressions like this, it's helpful to go ahead and combine them by getting a common denominator. So let's do that next. I'm going to multiply this fraction by sine theta over sine theta, if I can squeeze that in there. And then over here, I'm going to multiply times cosine theta over cosine theta. We're just getting a common denominator. And when I do that, my denominator would be sine theta times cosine theta. In the numerator, I have sine times sine, which would be sine squared theta, plus cosine times cosine, which would be cosine squared theta. Okay, so now I've got the denominator, sine times cosine. That matches what's on the other side of my wall, but I still have sine squared plus cosine squared on the top. Now, one of our other strategies was to, whenever you see squareds in your identity, check out the Pythagorean identities and see if one of them will work. And if you look at your Pythagorean identities, or if you happen to already know them, you know that sine squared plus cosine squared is equal to 1. So I'm going to change that to 1 over sine theta times cosine theta, which I do believe is now equal to, it doesn't look exactly like the other side, but I could write this as 1 over sine theta times cosine theta. So both sides of my identity are now the same, verifying that the original equation is always equal. Let's try one more of these. Again, my instructions say verify the identity, so I'm going to put up a wall between them. And I'm going to work on the two sides separately. Let's start over here on the left. I have 1 minus sine squared. Now remember, our strategies say that whenever we see squareds, we should try to use a Pythagorean identity. The Pythagorean identity that involves sine squared tells us that, let me move down here to the bottom, I'll write this down. It says that sine squared theta plus cosine squared theta equals 1. But what I have here in my identity is 1 minus sine squared. Well, I can easily get that by subtracting sine squared and canceling out over here. And I get cosine squared theta is equal to 1 minus sine squared theta. So this is another version of this same identity. The sine squared plus cosine squared equals 1 could also be expressed as cosine squared equals 1 minus sine squared. And so that means that back up here where I have 1 minus sine squared, I can replace that with cosine squared. And that's probably about all I can do on the left. Let's move over to the right side and see if we can do something over there. I have sine times cotangent over secant. Usually when there's no squareds, there's nothing to be added together. Our best bet here is going to be to get everything in terms of sine and cosine. So I'm starting out with sine x. So I'm going to keep that as sine x, but I'm going to put it over 1 because everything else is going to be a fraction. Cotangent x, I could write that as 1 over a tangent, but that's not going to be helpful to us. Remember, we're trying to get everything in terms of sine and cosine. So I'm going to rewrite cotangent x, actually, as cosine x over sine x. And then in my denominator, I have secant x, which I'm going to rewrite as 1 over cosine x. Now, we've got two fractions being multiplied and then another fraction being divided. So let's go, I'm going to rewrite my numerator. I'm going to go ahead and combine them together. Well, actually, if you notice, I've got a sine on top and on bottom in my numerator. Those can actually cancel each other out. And so my numerator, I'm just left with cosine x over 1 over cosine x. Now when I am dividing with fractions, remember that the rule is that you multiply by the reciprocal. So I'm going to keep the top fraction, cosine x, times, and I'm going to take the reciprocal of the fraction that's in the denominator. Instead of 1 over cosine x, we're going to write it as cosine x over 1. So now I have cosine x times cosine x, which is, of course, cosine squared x. And now both sides of my identity are the same. And we have verified that it is always true.